is 2 in the morning. 2 in the goddamn morning. And you just wanted me to keep on going. Well, you know what? Sometimes a man has to take a break. But we're back now. And last we left off, I was basically in the middle of debugging. We were doing some stack dumps just to see where we were failing, so that we could trace it back to, you know, what the floppy setup crap was up to when it did fall over. And it looks like, in general, the issue is probably that I'm not giving generous enough timeouts. Timeout delays. So might just start by trying to pad those out and see if I can get past that issue. And as always, good evening, where were we? So let's just hop right back into that. Let's see, that's not... Oh no, that is right. It's just, of course, my desktop is being silly again. There we go. It's perfectly fine now. Right, so, code. That's the thing we do. I had inserted some knops here. I'd really rather not have to do a nested loop in here. So how's about, actually we replace these knops with, because we can trash A. We're already trashing A. So why not use A? Sorry, just thinking. Because we could stash Y in A, at least for this one. Oh yeah, no, we could stash Y and A in both of them, because in the read FDC, A is going to get clobbered by the value we read, and we can toss, we can use A and Y to temporarily stash an extra counter between the two of them. And no, that doesn't make any sense, because we'd have to, we're clobbering A. I was thinking I could temporarily stash Y in A, but we're clobbering A, so that's crazy, but that doesn't work at all. Okay, so back to just using A in the first place, which also doesn't work because we're clobbering A. I'm losing my mind. No, my mind is booting up for the night and getting ready to operate. That's what's going on here. So how's about we go back to my old best friend and worst enemy, the old stack, and I guess what we can do is, I mean, I have the option of I could just throw a bunch more knops in here. That's always a possibility. Ooh. I wonder, did we confirm last time that the issue actually was it timing out? Because it could also be that it, well, I guess the only failure condition this does have is it timing out. I was going to say that, like, we don't get the register status that we want, but that's just when we don't get it, we try again, and we keep trying again, and that's the whole point of the timeout. Her derp. Okay, fine. Well, all right, back to my worst enemy in the stack. Load A. I don't know how long we want to go. We could add another 16 iterations, and then here we can push it. And if we get to here, instead of doing that, we can, let's do next FDC countdown loop. And actually, maybe let's let's load our iteration for there. Then we'll make next FDC countdown loop, and next FDC countdown loop we will reload X with FF, and we will before that, pull A, transfer A into X, DEX, and just do the same thing, really. If that one has counted all the way down, then we can jump to, what was it? What was the name of the label that I just deleted? Read FDC data fail. Read FDC data fail. And if we didn't fail, that is the case in which we didn't count all the way down, so we didn't just pop anything off the stack. So we need to make sure we pop that counter off the stack. And that should be done, I guess, right here. So we'll pull that value off the stack when we return a success result. Yeah, cool. And of course, so this will, as usual, be actually one less than what we loaded its value with, but that's fine. So it'll be 15 outer loops instead of 16, but whatever. Hopefully that will be good enough. So yeah, we load we load a hex 10 into A, push under the stack, and then at the top of this loop we pull it, put it in X, decrement it. If it hits 0, we go to read FDC data fail. Otherwise, we load X with FF, and then we decrease X. If that was 0, we go back here where we pull the outer counter off of A, check it. Yeah, cool. And then in here we do all of our normal stuff. The only thing we've done is added an extra loop. So let's add the same thing to the send FDC command. So, I mean, really, like exactly the same thing. What did I call this? That's a terrible name, actually. Let's update that. Next, sure. Next FDC read countdown loop. And then we can do the same thing with next FDC write countdown loop. And same old shit. Above that, we will load some kind of outer counter value. I'm going to stick with 16, and we will push that. And this one's going to be a little bit trickier. I need to pay attention because we are keeping other stuff on the stack too. But anyway, so pull it, transfer it into, pull it, transfer A into X, decrement, and if it hits 0, send FDC command fail, and this one changes from send FDC command fail to next FDC write countdown loop, and that's mostly good except, oh, I almost screwed myself up here. We need to make sure we push this value back on the stack for both of these. So let us transfer A to, or transfer X to A, and decrement, push A, so that it gets back onto the stack, which is why I had to rebalance the stack in the first place down here. Right here. Same thing. Transfer X back into A and push it. Okay, and then the last thing I need to do over here is for send FDC command fail. I think I just need to do a pull A here, just to, let's label these. Outer counter value, and then this is X, and this is A. Oh wait, no, that's FDC if it failed. If it failed, we already pulled this. We want to do this in the success case. here. Whatever. Cool. So I think that's pretty much it. Again, I'm gonna get rid of these knobs just because we're doing a whole extra outer loop, so why bother with those? Now, hopefully, this will give us a little bit more leeway. Let's see. Where I said, shouldn't you push back on the stack after decrement and check of 0? As usual, you caught me before I caught myself, but I caught myself. And if it is 0, you don't pull it again in the fail routine. Same story. Okay. Link it. And we shall see what happens. Doody-doo. Put it in the thing and aim it true. Load up some stuff into the buffer. Program the thingy, and then program another. Boom. Okay. Over here you go. Floppy power. Oh, right. I reorganized all my power over here. Now I need to figure out which cable actually is going to this. And try not to break things. At least try not to break them too badly. There we go. Oh, sorry. Wareham said, not sure if you've corrected it in both subs. I thought I had. I'm pretty sure I had. I guess we'll find out. Or not. Or it'll just be a little bug that... Yeah, my cameras have been being weird. I don't know what's up with that. I think I just need to restart my machine. Okay, so we had a failure. Let's see what it said. Dump the old 001B. U-doot. FA, that's fun. Got a little less on the stack, actually. Because before we were having it at F7, generally. Well, let's see. 01 FB. And dump me some stuff. I think that's the whole stack, and now these are just values. 1FB. So what is that? E2EE, E13B. And that's it. So let's look at some codes, I guess. Let me write those down. Let me write those down before I switch on over. But that is interesting. I think we're getting a different failure mode now. Sorry, my brain is glitching out. E2, E2, followed by E1, B3, E1, B3. Cool. What are those? This code is not accurate anymore. FCEUX.exe. How much debugging can deedly-dee? I'm going to debug with the debugger. Little known tricks of the trade. Okay, so what is E2EE? E2EE is E2EE would be right after this jump, and this jump is in something. E2EE. Oh, cool. So this is probably our overflow underflow. That's actually great, I think. Because if we bounce up one level, to E1B3. I bet that's in our startup code that's calling the read sector sub, which would be cool. And then, of course, we run into the trouble of the whole thing is I just fattened the hell out of the get data portion of the get data subroutines, and those are the things that need to be super trim for us to be able to keep up with the floppy. So I might just not call into the subs in the floppy routine. I may try and do some slimmer assumption making code in there, because like presumably this is interesting, because I think no, this is probably not a great think to have. I'm not sure if you get an IRQ every time the buffer fills up, or if you get an IRQ only when the transfer completes. But that might be one way to do it. I mean, we'll burn this bridge when we get there, but is wait for an IRQ, then suck as much data as we can out of the FIFO, or maybe just like 8 bytes out of the FIFO without even waiting for the RQM bit. And maybe that'll work good enough. Anyway, we'll get there. But anyway, just confirming the hunch that E1B3, E1B3, E1B3 is somewhere here. Okay, so that is right before a... God damn it. E1B3. You scroll and you just lose everything. So it's this call right here, right after a subroutine, subroutine jump, compare to 0. Let's see. Let's look for all compare to zeros. There are several of them. Let's look at the first one, because this is fairly early on in the code. Whoops, not that. CMP literal 00. Gotta escape that $sign. Oh yeah, it's probably this. Let's see, is it E1, B3, E1, B3. So I'm assuming it was this. Yeah, probably. Ooh, okay, this is store 04. Oh yeah, so this is our printing the string, then the call to print string, this guy right here. Yes, confirmed. And so this is the call to print string, then this is the call to FDC init, then this is the check to see if init failed, then this is the jump to init failure, then this is, wait. Yeah, this is the jump to the init failure check thing. Then this is, what is this? Select drive, that's what that is. Select drive. Is it? Comp 00. I mean, it definitely is. Compare, jump. This is our, yeah, this is the drive select. E1, yeah, and then E1. B1 is this call. Yeah. I mean, of course it would be, but just wanted to make dang sure. So that's good. That's good. That's good. Let me look back at the stack. That means we're getting as far as starting to read some sector data. And then it's giving us a error of some sort. So E223, let's go back there and check where that actually is inside of the read sector subroutine here. FDC read sector. Sector. Okay. E223 looks like E223 E223. E223, where do you be? E223. Oof. Wait. What? Nope, that's from yesterday. E1B3. There we go. That's the one. E1B3. 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 No, E2EE. Wow. We just were looking at E1B3. That seemed very familiar. E2EE. Back up we go. E2EE. 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 E2E. EE. It's gotta be here. Alright, so yeah, that should be easy to find because that is clearly, there is a store A indirect Y indexed, which has got to be this. Yes, FDC low buffer address. Yeah. And the actual call is just above a branch equal and a decrement. So branch equal, decrement, da. And that makes sense. Would be great to know like how many bytes we had read before it failed, but ah well. And then, so I wonder if this is good enough. This is probably our underrun, and then really in this case, probably what I should do is if we have an FDC read sector fail in here, I think that my code for handling that should really just like jump straight to here, because that's what's supposed to happen. It's supposed to dump the status bytes. No, that's still not, I don't know exactly how that's supposed to work. So like clear, I'm sure we're reading the status bytes before we over underflow whatever, and then we run out of data and then we bail out is almost certainly what's happening there. But we could probably get the right, what am I trying to say here? We could definitely see how much data we got, because we know where that buffer is, and we know what it's supposed to look like. So we shall just keep dumping until it looks bad. And then I assume we'll see the status bytes in there again, and it will probably look a whole lot like the first time we did this before we started introducing all of this error correcting crap. And then I guess we'll try improving the performance of those loops. See if we can keep up with the floppy. And finally, if not, we will see if we can knock back to double density today. On this very day, yeah. Right. So that buffer is at 0200, if I recall correctly. And dump. Okay, that all already looks totally incorrect. Like, really incorrect. Like, fascinatingly incorrect. As in, I don't even see valid status register values in there. Fascinating, Captain. Oh, well, no, I still don't know. Why would it timeout waiting for data there? Now, could this just be because it takes that long that when we get to waiting for floppy data to come in, even with the 256 times 16 wait loops that we're doing, it's still not long enough? That seems like it would be a long time, though. Like, what is 16 by 256 going to be? I guess, because that would be on the order of, like, I don't know, something like 3,000 cycle, or 3,000 iterations through the loop, and then the loop itself is like, I don't know, 10 instructions, and then the so that gets us up to like 30,000, and then the number of cycles per thing is like, I don't know, let's average it at 5. That would be what, 150,000 at that point, 150,000 cycles. So when you're running at 1.75 megahertz, that's still going to be milliseconds. It's possible. It's possible we're just not waiting long enough still. So for fun, just because that is so bizarre, and I feel like that's the only reasonable answer that I can come up with off the top of my head, I am going to bump that weight number way the hell up. Okay, maybe not way the hell up, but I'm going to bump it a fair bit. And see if that gets us any results. Or at least gets us any further into reading the sector. Because I would at least hope for a, you know, an overrun condition. I don't want these mocks anymore. Oh, also, I totally promised that I would do this last time. Get in it. There we go. Get status. What all do I... I'm just going to add everything like a gross person. Git add all. Git commit. Initial commit. Episode 42. That's fine. Do I care about my identity? Whatever happened to git add all, adding all of the things? The hell? Git add all. Git status. Yeah, that's fine. That's totally cool. Git commit. But it kept me from making a commit because I have no email address, right? I suppose is what it was complaining about. Commit -m. Yeah. Sure, whatever. Git config global user.email jmarlin at, I don't know. I guess this email is on my GitHub, so rip me anyway. Git config. Nope. Global user dot name. Joy. Okay, let's try that commit one more time. There we go. Thank you very much. Right, upping those numbers. We gotta pump them way up. I'm going to, I don't know, go with 80. Is that crazy? Fuck it. Let's go all the way. Let's just do 256 by 256, which is something dumb. Then you know you really have a problem. And same thing here. FF. Very good. Whatever. Why am I trying to do git commands? I just want to build the damn thing. We're linking, and we're thinking, and we're programming it up. Why am I doing that? I want to do this instead. Load some things. Right from here. Program it up. I don't even care. That's a lie. I care very much. Oakley dokley. Watch it be exactly the goddamn same. Pah. Patrick Burke says this is dope. Thank you, Patrick. I appreciate it. Stay with us for, you know, another 40 episodes and see if you still feel the same. But thanks for Thanks for checking in. I think it's pretty dope myself. All right. Okay, that seems goodish. I'm kind of surprised it failed so quickly the second time, but it did take a nice long time to fail the first time around. Oh. Wait. The hell? How did it get that far? How is that frickin' possible? It should have, if we had a failure, it should have gone through. Let's look at the code before making assumptions. But I looked last time, we were looking last time, to see where all the places that the attempt to read sector code could have a failure status. And it appeared to all be through FTC read sector fails. Or, sorry, FTC read data returning a fail status. So, let's just go through this really quick. Sure, we turn on the motor, which again, in and of itself, may not be long enough. But I mean, the motor is spinning this whole time, so I don't think that is a huge amount of concern. Excuse me. Plus, we already know we're reading stuff at this point. We just are having overflow, underflow issues. Okay, so we start sending the command. We go to send FTC command, see if it's 0. If it is, we go to read sector fail A. Like, is there any case in which, let's see, this FTC read sector indicates to its caller that it failed by, I believe, putting 00 in A? Just look really quick. FTC read sector fail, or no, okay. It puts a 01 in, and in that case, that's a failure. So, how can we be returning, in what cases can we be returning an 01 from here? And not have it be because of read FTC data? I fail to understand. Well, before I go diving into this, because it's got to be read FTC data, that is the only code that ultimately produces an error status. I'm not checking anything else. Well, anyway, before we do that, let me just go ahead and look in the floppy buffer just to see if we did get anything interesting. Oh, 200. It would appear to be Garbo. Just straight up Garbo. Should I go back to the emulator? Should I? Because the problem is, like I said, I don't know where and why and how I am managing to get to return from the sector read code without either succeeding, which we're obviously not, or passing through our FTC read or FTC write FIFO failure modes. That jumps to init. Oh. Wait. Because FTC reads... Oh, wait. Hold up. I might just be a fool. Because, let's see, we read FTC data because the status value is in X. I don't know. That seems fine. Have we ever had failures? Maybe read FTC data's failure mode just isn't correct. That could be possible. Because what I was gonna say was maybe I was checking the value of the A register coming out of this for status, but no, I'm not. I am using X. But anyway, the FTC get data stuff actually might not be working properly because I'm not sure that we've had a failure there yet, and that could make a lot of sense. Let's see, where's the top of this? Read FTC data. Is there a case where this... So FTC, read FTC data fail. Oh, wait. No, but still. If we get to read FTC data fail, we should definitely... We're putting the stack pointer on X, we're storing X into the SP value 0 page thing, and then we're jumping into init. So how I ask you, could read FTC data somehow pass a fail status and yet be working? Wait. This is very confusing. So if this fails, okay, so somehow we are either passing back an 01, which it doesn't look like that's possible, or we are not interpreting this return value correctly. That seems more likely. Maybe 'tis not failing at all. I mean, it's still going to fail, but maybe this isn't actually a failure here. So read sector, blah, 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 we set all that crap up. And then read FTC data, and my clever hack, we decrease X, decrement X, and if it had a 01 in it, which should be impossible to happen. The only case that I pass back an 01 and X is if we had a fail, but in the case that we had a fail, we jump back into the monitor first before we do anything else, so it wouldn't ever get back here. If it passes back a 0, and we decrement X, then it would be an FF, and BEQ would not be true. So what the hell? And same thing here. It's doing the same old deal that the other one is. So how the hell can this be happening? Oh, you're not looking at my screen. Old habit. Yeah, so check this shit out. When we come back from this, we are either there are only two cases. X is 0 or X is 1. X is 1 should never be able to happen. But if it did, X is 1, we decrement it, it becomes 0, this becomes true. But the only case that this should be able to exit in is if this is 0, which is the success case. And when you decrement 0, it should wrap around FF, and this should not be true, right? And that's the only way we get to the fail portion of this whole thing. Fascifrickin-nating. I am at a bit of a loss. Read FDC data. Okay. So if we manage to read 6804, we AND it with C0, we compare it with C0, and it is, let's see, because we branch if it does not equal C0 back to read FDC check. But let's say it is valid, it says I have some data for you, and this comparison is true, they are equal. Then we bop down to here, we pull A to throw away that counter, we load A 6805, which is reading from the FIFO, we load 0 into X, and we return. And when we get back, that's where we do the comparison, or that's where we do the decrement X magic, and it should be, I mean, the only way we'd get here is if it was a success, which we just looked at that decrement X thing, and that should proceed to be a success if we passed 0 here. And in the case that, let's see, in the case that this counted all the way down, hey, Taco Man, good to see you. I'm losing it. I have no idea. Somehow, let's just recap real quick. See how it says attempting to read a sector, failed to read sector? That seems good, right? Except no, that's super bad because it should, if there is any failure in here, it should be storing the stack pointer and jumping into the monitor. So I have no idea how we got here. I don't know how that's possible. I'm trying to find any failure mode that would possibly return us out of the read sector code with a failed status in a way that wouldn't first trigger dumping us back into the monitor. I am at a loss. Pull A, decrement X. Branch if it has hit 0 to read FDC data fail, which is down here, and that jumps us into the monitor. So how is this possible? How, I ask you? Worm said, well, the read sector counter runs out. Well, yeah, but we shouldn't even be getting back to a second try on the read sector counter. Conrad Punkoff says, this is such an interesting journey to be following along with. Super cool idea and impressive diligence and execution. Yeah, diligence, that's a thing. Thank you very much. I feel like diligence is all I have at this moment. But yeah, it's the only reason that the like this loop doesn't retry, or this this subroutine doesn't retry. The only place that it retries is when it fails out of this by jumping on down to FDC read sector fail, loading 1 into A to indicate that it was not a success, and returns to its caller, which is attempt read sector. This is the thing that counts down. That's fine. We should never be able to get back here on a failed condition. If we get here and this isn't 0, the only case in which this, I mean, let's trace it backwards, right? So if we compared this, okay, let's trace it back. If So we get out a floppy read sector, we compare what's in A with 0, which is our success status. If it didn't match that, then it tries another loop, which means it is not 0, 0, and the only other thing we ever set it to is 0, 1, but we'll go down that path in a second. So, because in the case that it was 0, 0, it's not going to take this branch, then it's going to print the success message, and then it's going to jump to init, which is not the thing it did, so we're not going down that branch. So that leads us to A was not 0, 0 here, which caused it to jump back to attempt read sector, which caused the second print of the thing there. That is a thing that must have happened. What could have returned us a not 0, 0 here? Well, let's go back to FDC read sector and look at all the places it returns. FDC read sector. And let's look for all RTSs. RTS, 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 RTS. So these are the only ones in the whole thing. So if we scroll up, doodly 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 doodly. Yeah, from FDC read sector, the only one we see are these two. One that loads A with 01 immediately before it returns, which is read sector fail, and one that loads A with 00 immediately before it returns. Obviously, this is never being hit, so it must be returning from this. We know that it's not 00 in A when we return, so it must be coming from this branch. Okay, what all things call read sector fail? FDC read sector fail. FDC read sector fail. Ignoring these for a second. All of the ones that we see are, so I mean we can not ignore those, but I'll come back to those in a second. The ones that call it directly are firstly at this label FDC read sector fail A, and then at FDC read sector, or at read sector byte loop low, it reads the FDC data, decrements X, and if that was the whole thing we were just talking about a little bit earlier, is that this magic should, if it was a 0, that'll wrap to FF. If it was 01, it will be 0, causing this to jump to read sector fail. So in order for us to get to FDC read sector fail here, this would necessarily have to, X would have to be 1. That's the only case where you decrement it and it becomes 0. Only case. So it has to be 1 coming out of read FDC data. We'll get back to that. Let's look at all the other cases where FDC read sector fail is called. Same thing, duplicate of the above code for the high loop, and then read FDC data, compare 0, 0. Ooh, that's actually somewhat interesting. Because that's wrong, right? That is incorrect. Here we should be checking X. So that actually did end up being something interesting. Now, I don't know how it could get through both of these loops, not fail somehow, and then get here and fail. Maybe we're being super lucky and we're not having an underflow? That would be interesting. Or we're not having an overflow. We are, in fact, having an overflow. Oh my god, you guys. This is one of those nights. I look over, Taco Man, switch the screen, look immediately up to the left of that, and you're just looking at a spinning floppy. This is one of those nights. This is one of those nights. I'm not going to backtrack on that. I'm just going to make the apology, and I'm going to push on forward. So, here's what I'm saying. I may have just found a thing. This is a possible, yeah. If we do read FDC data in any of these, and the data that's returned is 0, it will mark that as a fail. And not because read FDC data actually failed, because we are comparing on A, which actually we should be comparing on X. UC. And yeah, we can use the same hack here of the DEX thing, because read FDC data returns its success fail status in X, not in A. So that is a bug. Maybe it is our bug, but the interesting thing is that means that it managed to get through both the high and the low read loops without having an issue, which would be surprising. But this is the only thing I see so far, so why not give it a chance? And this will become BEQ. Same thing here. DEX, BEQ, DEX, BEQ, DEX, BEQ, DEX, BEQ, DEX, and BEQ. And do you know what this one's going to be? It's actually going to be a DEX, and then this one's going to be a BEQ. I'm telling you, I'm not making it up. That's exactly what it's going to be. And there we go. So it would be really weird if that made everything work. Also, we have garbage. We have absolute garbage in the buffer, in the floppy, in the sector buffer that we're writing to. So there's no flippin' way. There's no flippin' way. Unless I'm just reading garbage out of the floppy somehow, which I don't know how that'd be possible, because I don't know why it would have bits available to me. Anyway, this is the only thing that I see that strikes me that could possibly go down that route of returning a failure back to the top level code from read sector without actually failing inside of the get FDC FIFO data and send FDC FIFO data calls. So yeah, give it a program, turn it all off. Gerald says, hi bye, damn YouTube alerts. Ooh, pretty cam is really glitchy on my end. LSD trip. Yeah, it's been weird. I think I need to reset everything. It could also just be that camera's on a really long cable that is probably longer than the USB spec is supposed to support. And it's losing its shit. Okay. Program. I'm back. Alright, let's watch it do the exact same freaking thing. Though I think that's what I said the last time that we programmed it, and it did this whole different weird thing, so I mean, maybe it'll at least be different in a fun way. Taco Man said, please work this time. No. Way too easy. No fucking way. I promise you that is not true. Yeah, because it dumped an 80 in. It sent an 80 incorrect command and then a shit ton of Fs. And a bunch of 80s, and a bunch of Fs, and a bunch of 80s, and a bunch of Fs. Yeah, about that. Dave says, be optimistically pessimistic. Yeah. Agreed. Yeah, this is fascinating. I don't know really how this is possible. I've kind of seen it give me this sort of data before, but like, how is it at all possible that I just wait long enough and the RQM bit eventually just turns on? Because that's what would have to happen here for it to even say there's anything for me to read. And I haven't sent any new commands in the middle of those loops, so and on top of everything else, it's not even sending me whatchamacallit, like the status data. It's like if it was an overrun or an underrun, it should be sending me 7 bytes of here's why your shit failed or didn't fail data. Fascinating. I don't understand at all. Not even a little bit. What is going on here? So here's where we're at. This was where we had the issue. Somehow, read FTC data is in fact returning. All good, I got bytes for you, Jack. Which is nonsense. Could it be that that subroutine in and of itself is totally effed? We don't really use it for much prior to this. Could be. Might be. Because everything up to that point seems to be okay. We know send FTC command, like, we've debugged that a fair bit. I trust that pretty well at this point. So, and none of those are failing prior to this point. But when we get to here, when we get to here, it is semi-untested. We don't really rely on read FTC data too greatly prior to this loop. So, is it totally possible that this is just returning all happy, like, instantly, and there is in fact not any data ready for us to read? Maybe? Could that be the case? Yeah. Let's look at it. Let's look at it again. So that is read FTC data. We load AFF, push on the stack. Then we pull it back off the stack, put it in X, decrement it. If it hits 0, we jump to read FTC data fail. Otherwise, we are an idiot. Interesting. Okay. Huh. So I just realized one place where it's fucked up, which is that, and it might be fucked up for both of these, we are definitely, obviously, corrupting X here, because... Wait, no, we're not. This is just taking X, putting it back in A, and pushing it along. Then we load X with F. Right, sorry. No, we're not corrupting X. That's fine. Good. I'm not that stupid. Okay, so we've checked that. It's decremented. It's put back on the stack. Then we load X for the inner loop. We decrement it. We check if it hits 0. If it did hit 0, we go back here. We pop the thing off the stack to try again. Then we go here. We read 6804. We AND it with C0, and we compare to see if it is C0. And if it was not C0, which C0 is the I have some or I want to do a transaction with you, and I want to send you data, my friend, setting. So if that is the case, and if it's not the case, we go back to read FTC check, we decrement X, blah blah blah, we do that whole shebang over again. But if it was good, then we pull that thing off we pull that counter off the stack because we don't need it. We load the value out of the FIFO, and we set the success value in X, and that's that. We return. And if we fail, we should jump into the monitor, as discussed. So, am I, like, totally getting this wrong? Is this not how you check to see if it's ready to send you stuff? Is that possible? Gerald says there is a BF in there among the 80s and FFs. That's fun. I guess it's still garbage, but it's good to know. Wereworm said, "Did you check the DIO flag? I mean, if you read what the FDC expects you to write the next command, yeah, that's what the CO is about. Is that bit 7 is the RQM, and this is what I was going to say is maybe let me check the data sheet because maybe I have my bits wrong. That could totally be possible. But bit 6 is DIO, right? And so for the FDC to be saying, I want to send you a byte, or I have a byte available for you, they would both need to be set to 1, which is what this is checking. But let me check that assumption. Let us check the DIO definition. Proper way to issue a command. Yeah, because I stole this shit from here. Yep, it is. It's bit 6. That was correct. There's the NDMA thing, which gets set when we go into execute mode, but that's a whole different thing. Dirt Piper says, "Is this a known working floppy drive? We have read data from it before. If y'all want, for fun, we can switch to the GoTech. Now would probably be a half decent time to have some fun playing with that, but I don't expect a difference because this is the floppy controller at this point. That is doing shit. Why not? Let's go ahead. Let's go ahead and do that. At least that will be fun and interesting. Now, I have not used a GoTech before. I understand they're supposed to be pretty easy, but I haven't used them before, so might look stupid. Wouldn't be the first time. Okay, let me make sure I get my powers right. Turpiper says, if the GoTech miraculously works, you owe me a beer. I'll buy you a beer anyway, but I have my doubts. Again, we have read data off this floppy drive. That's the fun and annoying thing. We couldn't keep up with it. We had an overflow or underflow or some kind of thing. But we did it. Data was read. Now, could it be that this is getting corrupted in some way? Maybe, it's possible. But that data that I'm seeing in the buffer is all total garbo. Like, it's obvious garbo. It's got a lot of 80s in there, and 80 is the FDC. I don't have data for you. I don't know why you're asking me for it. Value. Which is extra bizarre, because we just checked the RQM. Obviously, there is a code issue here, but look, it's an excuse to use the GoTech. Let's use the GoTech. Let me get So is there anything special I need to do in the naming of these bad boys? I guess I could look up the documentation. GoTech manual. And do I even have an open USB port at this point? Kind of? Okay, USB, plugged in. I don't know what that's formatted as. But I can find out. I think it's FAT32. I think we're fine. Yes, it is FAT32. We should be good. I'm going to delete all the shit on here, though. Yes, that is fine. You can do it. You can do it. I believe in you. Okay. how do we put shit on a GoTech? And in the meantime, WinWorld PC seems like the place for cool floppy images. Let's go with, I don't know, I guess the same DOS boot disk. I can't remember what version of DOS this is now. What am I looking for? MS-DOS CP/M, MS-DOS. Was I using 310? I don't remember. I don't know, whatever. If we don't see obvious garbage, then that's a start. And what kind of floppy are we looking for? 3.5, 3.5720, 3.5720, 3.5, okay, that's too old. What was it, 331 that I was using? 3.51, yeah, actually I do think this was it. And GoTech, how do I do some stuff? Format the stick in FAT32, copy the hxtt file onto it, which I get from somewhere. Must be here. Hopefully this is it. In the meantime, let's unzip this, some more fun. Right into the downloads folder, the best way to organize files. Downloads. Downloads. I am on my desktop. What is wrong with me? Downloads. What am I doing? Where is the folder? That was just made. It's right there. I just saw it. Okay. All right. So that is what I would like to get on the GoTech. Boy, this is taking a long time for a 50 meg file. HFE. The file extension can be one of the supported image. Okay. So HFE is probably a red herring. Normal mode. This is the default floppy emulator mode. In this mode, you can browse files, but I do not have an LCD or LED version. Configuration files optional. Sure, whatever. Oh, what? Normal mode, index mode, bloobity-doo. I like how they don't really tell me what that config file does. That's neat. But I'm guessing I have to use index mode. Config files, indexed mode. What is in here? Interesting. Well, anyway, I understand I copy this to the root of the floppy? Is that how that goes? Is that what they said? Did I say the root of the floppy? Just don't even worry about me. So what was the naming convention here that they said that I just read? Indexed mode. I guess let's name it like this. And again, supported images are IMG is fine, you say. Very well. Then I'm going to take this and put it on the Floppy I said Floopy again. Not the Floopy. The USB. And rename it. And call it a day. Okay. We'll see if that works. Never used a GoTech in my life. Eject. Flash drive. Gotta make sure it's safe. I don't know what USB disk 2.0 is, but I'm going to get rid of that too, just in case. All right. Here it is. We have our GoTech thingy. Are you using HX? I don't know what I'm doing, for the record. I just looked up GoTech stuff, and apparently, did I just do a wrong thing? Are you using HXC firmware on your GoTech? I use Flash Floppy. Never felt like paying for HXC. I'm sorry. I don't know what I'm doing. Let's back up a step, because Dave raises some questions that make me realize I don't know what the hell we're talking about. Oh, it's enhanced firmware for GoTechs. Interesting. Didn't know that. I just want to use whatever the default thing is. Let's see. What is Flash Floppy? Floppy drive emulator for GoTech hardware. What even is going on here? I clearly knew even less than I thought I did about GoTechs. How to use a GoTech. Someone help. I don't know. Maybe this page will help. Say goodbye to old and unreliable floppy disks. It's the number one. Supports a whole bunch of stuff. Do you have a what I'm supposed to do? Okay, Dave says, stock they come with proprietary firmware that does basic floppy emulation, usually of 1.44 meg floppies. Flash Floppy gives you choices of what to emulate. Okay. I still need to look at a manual to understand how I use the default firmware, because apparently I haven't seen anything on how to actually use the default firmware. Maybe this will be useful. This also has HXC stuff on it. Wait. They just casually start talking about the HXC stuff without letting you know that there's anything special or different about it. Oh, interesting. Okay, can I download Flash Floppy? Ah, right. They're saying use Flash Floppy. And you get this config from HXC compat mode. Neat. I guess let's, yeah. Look what's in here. Maybe this will be more obvious now. Maybe read the README. Probably a good idea. If programming a factory fresh GoTech running factory firmware, you'll need to program, like, you need to actually flash this shit. How do I just use... I have a 1.44 meg image, bro. Um, I just want to use 1.44 meg image with the vanilla firmware. I mean, do I... Can I... Like, this doesn't say anything about needing to burn new firmware to your GoTech. But maybe they just have a nice GoTech that happens to already have flash floppy on it. I don't know. I don't know. Dirt Piper says, I have granted you with a diversion from the stress of the interface with the controller chip not working. Honestly, you're not wrong, man. I'm half feeling like maybe for that shit I will just take it offline for a little bit, because, or like, you know, do some off-camera work on it, because it's pissing me off, and it's hard to like concentrate and be on camera at the same time. I'm thinking about it. Not that I would drop episodes, but just work on it off screen. Also, it's starting to get, I feel like, not especially entertaining. Anyway, I'm just going to do what they say in that Amiga thing, and take the flash floppy shit, and just take the HXC config, and, or the HXC compatible one, and just drop it on there, and copy it, and drop it into the disk, and overwrite that one, and just see what happens. Probably nothing good. All right, now let's make sure we safely eject our USB disk again. And yeah, this is going to be the fun thing. Now I have to debug two things, apparently. My GoTech and my floppy controller. Are you guys just fucking with me? I mean, maybe. Let's see if it does anything. I don't know. Hello, Santiago. What's up is I've been going for almost an hour and a half, and oh yeah, no, the main camera is freaking out. I'm going to shut it all down shortly. Anyway, that's on. Let's just see what it does. So, I promise you, it didn't actually succeed. I guarantee you, it did not actually succeed. The activated light came on the GoTech though, so that's a thing. Ooh, that's fun. Anyway, let's see what's in the buffer. I owe somebody a beer. I owe Dirt Piper a beer if this just worked, but there's no fucking way. Oh. Fuck off. There's no way. Is that it? Is that right? Is that... Fuck. Yeah, I don't know what an air... Does it say, like, air? Okay. Alright. Listen, motherfucker. This proves nothing. Firstly, we still have the weirdness that it, even though we got the first several bytes out of it, it still says that it read it just fine. And it did not read it just fine. It should have timed out on one of those reads. Eventually. So that's a thing. Anyway. This is, I'm still not sure about the GoTech, because as you can see, I haven't learned shit here by plugging the GoTech in. I haven't learned shit. I have learned that potentially that other floppy drive didn't work, or that I'm not handling it in just the way that it wants for real hardware, but the GoTech isn't as picky, and so I have learned jack shit. And I have learned jack shit about why we could possibly get all the way through the attempting to read a sector part, because, as you can see, we definitely don't have all of the data. it read a bunch, and then I'm sure did an overflow and took a credit, because now it's all Fs. How could we possibly be reading Fs? We would have to have RQM going high, and the direction pin and the direction bit going high, and yeah. So we're getting somewhat lucky here, but there's still a big question on how is it able to get this far? In the first place. Oh yeah, and it is definitely saying that underflow thing again, because it's EB589041 blah 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 blah. But it ends with O2. And O2 is the kind of sentinel value for the end of the result bytes, or the status bytes. And I'm sure that's saying it's the overflow again. What is the 40 and 10 status? I am quite certain that is the same overflow underflow thing, which helps me not much, because I mean it takes us back to where we are, but now I guess now I can try and keep up with it, but I still need to figure out how we're able to get all the way to the end of the reading a sector without any indication of any failures. And yeah, all of that good stuff. Because that ain't right. Oh, I wonder... No, that doesn't make any sense. Don't listen to me. I don't have any ideas. Every now and then I feel like maybe I have an idea, but... Okay. Anyway, let's do the thing like Taco Man said. I'm just going to restart it and make sure we get the same shit. I guarantee you we will. Cortec initialized. And doop. And O2, boop, boop. Yeah, it's going to do the same shit. And look, exactly the same. So I guess here's what we can do, is at least to make some kind of progress that's not totally brain-numbing. Tomorrow, because I've already gone to the end of my streaming time. But tomorrow, oh, and I'll check that status really quick though. But tomorrow, I guess we can at least try to optimize this so that this much works. With the GoTech, with it always succeeding and being perfectly beautiful. And then we can get the regular floppy drive on there and work out what why it hates us with real hardware. And in either case, also still work out how this is acceptable to our code. How it can be successfully reading data from the FDC when there's no data to be read. Yes, fascinating. Anyway, let us look at that status stuff. So it is 4010, and we've looked at this a few times, but let's just humor ourselves. Go to the datasheet. Look at the status registers. Control F. Status register 0. Wait 3 days for this PDF to render. Okay, so the first one we get is SR0, and that was the 41, right? That is 40 correct. So what is in bit? That's bit 6. Bit 6 is the interrupt code, so that means it is an 01. That's the abnormal termination. Universally 40 is abnormal termination. There was some shit went down, friend, is what that is saying. Then it was 10, and that would be status register 1, Ah, that's fun and interesting. No way, that's right. $41.0. Oh, 1, not 8. 1. I'm going the wrong way around. So that would be bit 4, actually. Overrun, underrun. Yeah, which makes sense, because we ran out of data, and then got all Fs. As expected. Alright, case closed. Let's all jot that down in our brains. 4010 is an underflow overflow. There you go. Alright. On we will go into episode 43, where we will at least. Well, there's actually two things I want to do, because I want to be able to detect an overflow, underflow. So as you can see, I mean, that's part of why I wanted to write all of this error checking code. Is this is the big one that I want to check, is overflow and underflow. Because if for whatever reason we can't keep up, I want to know about it. In this one, it's just silently succeeding, which is totally bizarre. Anyway, I will stop whining about that, but that's what's currently happening. That's bad. But either way, I don't actually have checking code in here for, like, the code has no idea that an overflow or an underflow happened. As far as it's concerned, it just read 512 bytes of data, and it's like, super cool, champ, here they are, they're mostly Fs, have fun. But there's supposed to be a way to tell that you overflowed or underflowed, and I need to check out what that is. So since we are back to the place where, at least with the GoTech, we're getting an overflow, underflow, because whatever real world hardware shit that we're not doing properly is at least ignorable for now. We can, yeah, let's start by trying to detect that situation and throw an error in that case, because right now we're not. And then once we have that going, try and optimize our shit to see if we can keep up with it, if it's even physically possible to keep up with the damn thing and get good data. Where I'm said, if you set the FIFO to give an interrupt at 8 bytes, you can read 8 bytes without checking the status again. Yeah, I don't know if maybe you missed a spot, but I was kind of suggesting that exact same thing. Was that maybe for the most performant thing is that I just wait for the IRQ bit, and as soon as I get an IRQ bit, just read 8 bytes. Don't even wait for the RQM settings. The only problem is, if it has any kind of hardware issue in the middle of doing that read, we won't know about it. But I think that is the fastest way to do it. I might just try starting with that from the start and seeing if that works, because I can't think of a faster way to do it. And if that works, that works. Anyway, more tomorrow. Remind me when we get on, because I will certainly forget. First task for tomorrow is figure out how we detect overflows and underflows in software, because I want to be able to do that. Only problem is that might slow down our reading code. We're balancing things here. It's engineering. Always trade-offs. But anyway, until tomorrow, when this saga crawls on its hands and knees into its next phase, I will see you, I love you, and goodbye.